Imagine holding the keys to understanding your body's most complex ecosystem. A microscopic universe containing trillions of microorganisms that influence everything from your mood to your immune system. What if you could learn to read this inner landscape and help yourself and others achieve optimal health? Welcome to the fascinating world of human gut microbiome analysis, where science meets personalized wellness in ways that were unimaginable just a decade ago. The human gut microbiome represents one of the most cutting-edge frontiers in medical science. This complex ecosystem of bacteria, viruses, fungi, and other microorganisms plays crucial roles in digestion and nutrient absorption, immune, system development and function, metabolic regulation and weight management, mental health and cognitive function, and chronic disease prevention and management. Learning to analyze gut microbiome data puts you at the intersection of medicine, nutrition, and data science. This skill is increasingly valuable as personalized medicine moves from theory to practice, and as more people seek science-based approaches to optimize their health. The science behind microbiome analysis begins with understanding the microbiome composition. The human gut microbiome consists of thousands of different species of microorganisms, each playing specific roles in maintaining health. The most abundant bacterial phyla include firmicutes, often associated with energy extraction from food, Bacteroidetes, important for breaking down complex carbohydrates, actinobacteria, which includes beneficial species like bifidobacterium, and proteobacteria, often associated with inflammation when overrepresented. One of the most exciting areas of microbiome research is the gut-brain axis, the bidirectional communication system between the gastrointestinal tract and the central nervous system. This connection influences neurotransmitter production including serotonin and GABA, inflammation levels affecting brain function, stress response and anxiety regulation, and cognitive performance and memory. Understanding this connection opens new possibilities for addressing mental health through gut health optimization. Learning microbiome analysis requires a systematic approach. Start by building your foundation in microbiology. Understanding bacterial classification and nomenclature, culturing techniques and limitations, DNA sequencing basics and metagenomics, and bioinformatics fundamentals. Next, master data analysis tools like QMAT4 for microbiome analysis, R programming with Philosec packages, Python for microbiome data processing, and statistical analysis methods for microbial ecology. Then, study how microbiome analysis applies to real-world health scenarios. Learn about gut dysbiosis and its health implications, microbiome-based interventions including probiotics and prebiotics, diet microbiome interactions, and personalized nutrition approaches. Finally, develop interpretation, skills to translate complex data into actionable insights, identifying microbial signatures of health and disease, understanding alpha and beta diversity concepts, analyzing functional potential of microbial communities, and correlating findings with clinical outcomes. Here's a thought-provoking question that combines mathematical thinking with practical microbiome knowledge. If you have a gut microbiome sample containing 1,000 different bacterial species, and you discover that 3 of the total bacterial count consists of a newly identified species Microbius beneficialis, while another species Dysbiosis disruptus represents 5 of the total count, how many more individual bacteria would you expect to find of Dysbiosis disruptus compared to Microbius beneficialis in A? Sample containing 10 million bacterial cells. What does this ratio suggest about the balance between beneficial and potentially problematic bacteria in this individual's gut ecosystem? With 10 million total bacteria, Microbius beneficialis would represent 300,000 cells 3 of 10 million, while Dysbiosis disruptus would represent 500,000 cells 5 of 10 million. This means there would be 200,000 more Dysbiosis disruptus cells than Microbius beneficialis cells. The ratio of 5:3 in favor of Dysbiosis disruptus suggests an imbalance that might indicate suboptimal gut health, as potentially problematic bacteria outnumber the beneficial species in this case. By analyzing an individual's microbiome composition, you can recommend specific dietary interventions, identify foods that promote beneficial bacterial growth, suggest probiotic strains tailored to individual needs, and help optimize nutrient absorption and minimize inflammation.
Microbiome analysis also helps in early detection of gut dysbiosis patterns, monitoring treatment effectiveness for gastrointestinal disorders, predicting responses to medications and therapies, and developing preventive strategies for chronic diseases. The gut-brain connection opens new possibilities for addressing anxiety and depression through gut health optimization, improving sleep quality and stress resilience, enhancing cognitive function and mental clarity, and supporting overall brain health and neuroprotection. These applications demonstrate how microbiome analysis can be applied across multiple dimensions of health and wellness. To get started in this field, consider online courses and certifications such as Coursera's Microbiome Analysis and Personalized Medicine, edX's Gut Microbiota and Human Health, and specialized certifications from leading microbiome research institutions. Follow key journals like Nature Microbiology, Cell Host Microbe, and Gut Microbes to stay updated with the latest research, and read systematic reviews on microbiome disease associations to build your knowledge base. Participate in citizen science microbiome projects to gain hands-on experience, work with clinical data under supervision when possible, and collaborate with healthcare practitioners and researchers to understand real-world applications. Build your network by connecting with professionals in the field, stay current by following the latest research and attending relevant conferences and webinars, and practice regularly by working with real microbiome data to develop your analytical skills. As research advances, microbiome analysis will become increasingly integrated into mainstream healthcare through emerging technologies like real-time microbiome monitoring devices, advanced AI-powered analysis tools, personalized probiotic formulations, and microbiome-based diagnostic tests. However, important ethical considerations must be addressed, including privacy and data security concerns, access and equity in microbiome-based healthcare, regulatory frameworks for microbiome interventions, and long-term safety and efficacy monitoring. The future of microbiome medicine holds tremendous promise for improving human health through personalized, preventive approaches. By leveraging the power of microbiome analysis, healthcare practitioners and researchers can develop targeted interventions that address the unique needs of each individual based on their specific microbial composition. Learning to analyze human gut microbiome data puts you at the forefront of personalized medicine and preventive healthcare. This valuable skill combines scientific knowledge with practical applications that can genuinely improve lives. As our understanding of the microbiome continues to grow, so does the potential for innovative health interventions and personalized wellness strategies. By mastering microbiome analysis, you'll not only gain specialized knowledge, but also contribute to a future where healthcare is more precise, preventive, and personalized. Where each individual's unique microbiome signature guides their journey toward optimal health and well-being. The journey into microbiome analysis is challenging but incredibly rewarding, representing the perfect intersection of science, technology, and human health. A field where your knowledge can make a tangible difference in people's lives. Technology and human health. A field where your knowledge can make a tangible difference in people's lives while expanding the boundaries of what we know about the human body and its complex relationship with the microbial world.
Imagine being able to detect diseases years before symptoms appear, just by noticing subtle patterns in everyday data. This isn't science fiction, it's the emerging field of diagnostic pattern recognition, where ordinary people can learn to spot life-saving clues that even sophisticated AI systems often miss. In a world overwhelmed by medical information, the ability to recognize patterns has become an essential survival skill. While technology advances at breakneck speed, human intuition, when properly trained, remains our most powerful diagnostic tool. This skill bridges the gap between raw data and meaningful insight, potentially saving countless lives through early intervention. Our brains are pattern recognition machines, processing up to 11 million pieces of information every second. However, most of us use only a fraction of this capacity. Medical pattern recognition works by training your brain to filter relevant signals from noise, creating mental shortcuts that become more accurate with practice. If a diagnostic test has a 95% accuracy rate and gives positive results to 1 in 100 people in a population of 10,000, how many actual positive cases would you expect to find among all positive test results? This seemingly simple question reveals why context and pattern recognition matter more than raw numbers alone. Practical applications include early disease detection through recognizing subtle changes in skin tone, eye movement, or gait that may indicate neurological conditions. Mental health patterns can be identified by spotting behavioral shifts that could signal depression or anxiety before crisis. Nutritional intelligence involves recognizing nutrient deficiencies through skin, hair, and nail observations, while environmental health requires recognizing patterns in local ecosystems that may indicate public health risks. To develop this skill, start with systematic observation of small details. Create mental frameworks for categorizing patterns. Practice with real-world case studies. Combine intuition with evidence-based verification. And build a pattern library through consistent practice. As healthcare becomes increasingly personalized and preventive, pattern recognition skills will become invaluable. They empower individuals to take proactive roles in their health while complementing rather than replacing medical expertise. In developing regions with limited access to advanced diagnostics, these skills could be life-saving. Begin today by choosing one area of health observation, skin changes, movement patterns, or behavioral shifts, and create a simple tracking system. Consistency matters more than complexity. Over time, what begins as casual observation will evolve into sophisticated diagnostic intuition that could help save lives.